Implicit differentiation is a technique used in calculus to find the derivative of an implicitly defined function. To perform implicit differentiation, follow these steps. Step 1. Determine which variables are present in the equation. Step 2. Treat each side of the equation as a function and differentiate it with respect to the desired variable. Step 3. If the variable you are differentiating with respect to appears in terms involving other variables, apply the chain rule to account for those dependencies. Step 4. Rearrange the equation to isolate the derivative term on one side. Step 5. If possible, solve the equation obtained in the previous step for the derivative. It's important to note that implicit differentiation can lead to equations involving both the desired derivative and the original function, so it may not always be possible to solve explicitly for the derivative. Here's an example to illustrate the process. X squared plus y squared equals 25. It's an implicit equation. To find dy dx, the derivative of y with respect to x. Using implicit differentiation, let's follow the steps mentioned earlier. Step 1. Identify the variables involved. In this case, the variables are x and y. Step 2. Differentiate both sides of the equation. Dx, x squared plus y squared, equals dx, 25. This becomes dx, x squared plus y squared, equals 0, because the derivative of constant term is 0. Step 3. Apply the chain rule. Since we have the term dx, y squared, we apply the chain rule to differentiate it. The derivative of y squared with respect to x is 2y times dy dx. Step 4. Isolate the derivative term on one side. 2y times dy dx equals negative 2x. Step 5. Solve for the derivative. Dy dx equals negative 2x over 2y. Simplify it. Dy dx equals negative x over y. So, the derivative of the circle equation with respect to x, dy dx, is equal to negative x over y in this case. Remember to be cautious with implicit differentiation as it may introduce additional terms and complexities in the resulting equation. See you next time.